Okay, good morning, all of you. So today we are going to discuss that the last part of this topic, and that is nothing but the logic gate. And I think you might be familiar with this all logic gates. You have already studied that. Still, this is just type of one type of a revision. Okay. So what is mean by that logic gate first? So logic gate is the small circuit. It's a small circuit, but it can be acts like a basic building blocks of any digital circuit is that. The logic gate is a small circuit which has one or more than one input, but only one output. And the output of this gate is depends upon the type of the circuit is there. And based on the type of the circuit, there are total these three and these four, there are so seven logic gates are available. Is it right? So how you can define that logic gate? The logic gate is a small circuit which has one or more than one input, but only one output. And the output of that circuit is depends upon the type of the circuit and the input to the circuit is that. So this is called as the logic gate. And we say that these logic gates are the basic building blocks of the any digital circuit is there. It means that the digital circuit is always, as you know that when I say that the digital circuit, it means that it has its only two signal, one and zero. And the logic gate is also gives its output in the form of one or zero, or we say that high or low. Now, as I said that depending upon the type of a circuit and the type of that input, we will get that output from that circuit. And based on that, there are total seven types are there. But out of that, these first three gates, which are these first three gates? AND gate, OR gate, and NOT gate. These gates are called as basic logic gate. Basic logic gates. And then by using these three basic logic gates, we can derive four more logic gates. And these are these four more logic gates, so that these logic gates, we call it's a derived logic gate. Derived logic gate. So most of the time, the question it may also ask like that, what are the basic logic gates? So there are total three logic gates are we call as a basic gate, and these are nothing but AND, OR, and the NOT. And by using these three gates, we can derive, we can construct, we can prepare these four more logic gates, and these logic gates we call it's a derived logic gate. If you try to read it, NAND gate, NOR gate, XOR gate, either you can write XOR gate in this way or XOR in this way is there, or XNOR gate is there. Okay. And another one important thing is that out of these seven logic gates, NAND gate, NAND in all letters must be in capital. NAND gate and NOR gate, these two logic gates we call as a universal logic gate. Universal logic gate. मग आता याला युनिव्हर्सल लॉजिक गेट का म्हणलं गेलेलं आहे? या दोन गेटला कोणकोणते आहेत बघा, व्यवस्थित बघा. नॅन्ड गेट आणि नॉर गेट, या दोन लॉजिक गेटला युनिव्हर्सल लॉजिक गेट का म्हणलेलं आहे? का तर बाय द रिपिटेटिव्ह यूज ऑफ दीज टू गेट, म्हणजे नॅन्ड गेट यूज करून आपण अँड गेट बनवू शकतो, ऑर गेट बनवू शकतो आणि नॉट गेट बनवू शकतो. मग जर नॅन्ड गेटचा यूज करून जर तीन बेसिक लॉजिक गेट बनवता आले, याचाच अर्थ कुठलेही लॉजिक गेट्स आपण तयार करू शकतो, अँड वी कॅन डिझाइन एनी डिजिटल सर्किट इज दॅट. दॅट्स वाय द नॅन्ड गेट इज ऑल्सो कॉल्ड ॲज अ युनिव्हर्सल लॉजिक गेट. सिमिलरली नॉर गेटचा सुद्धा आपण यूज करून अँड गेट मिळवू शकतो, ऑर गेट मिळवू शकतो, नॉट गेट मिळवू शकतो. म्हणजे तीन बेसिक लॉजिक गेट जर आपण नॉर गेटचा यूज करून जर प्रिपेअर करू शकलो, मिळवू शकलो, तर याचाच अर्थ नॉर गेटला सुद्धा आपण काय म्हणणार आहोत? universal logic gate is there. So now what we are going to discuss in this session, we are going to discuss that the three part. One is the symbol of the logic gate. Second thing, it's a truth table of the logic gate. And the third thing, which is nothing but the Boolean equation of a logic gate. So these three things we are going to discuss about all these 7 logic gates. And after that, we are going to discuss that the NAND gate and the NOR gate separately, as they can act as a universal logic gate. Then we will give the proof for how these 2 logic gates are acts as a universal logic gate is there. Okay. So many MCQs will be formed by using this slide. So please take a screenshot of it. Okay. Now, one more thing is that due to the time constraint, we are not going to discuss that the circuit diagram. As I already said that by using the diode and the transistor, we can try to prepare these all logic gates. But when I try to explain that by using the circuit diagram, definitely it will take a lot of time. And as your exam is that MCQ type of exam, so nobody will ask that draw the circuit like this. Is that right? So forget about it. So, but I will try to prepare that one separate video based on the circuit diagram and how it actually works. But right now, we are going to give that the more focus on these 3 things only: the symbol, truth table, and the Boolean equation. Is it right? But if you try to go through the teaching diary, where I have already uploaded the teaching notes, my scanned teaching notes, in that teaching note, you can definitely find the circuit diagram using the diode and the transistor. If you are interested to study that the circuit diagram, then in my notes already I have uploaded on the teaching diary there, so you can go through it. Okay, so let's we try to discuss the first basic logic gate. This is, we call it the basic logic gate. Why we call it a basic logic gate? Because this is the basic building block of a digital circuit. We call it a basic logic gate, first logic gate. Now see that what is the symbol of the AND gate. The first thing is that the symbol is like this. All of you please concentrate. The AND gate having a 2 input and 1 output is there. So this is the symbol. These are the 2 inputs. I say that input A and input B. These we call as a inputs, and this is an output. I say that Y. This is an output is there. So this is the symbol of a AND logic gate. If you see that the 2 inputs are there and only 1 output is there. So when the 2 inputs are there, so what are the possible conditions are there? Now, actually, how this diode or this AND gate, how this AND gate it actually works. So the working of that AND gate, it is written in one tabular form, and that is called as a truth table. What we call as a truth table. And this truth table is the relationship between the input and the output. This truth table is relation in between the input and output. So what are the inputs are there? It's A and B. And what are the outputs are there? It's only 1 output. We say that it's a Y. As this is a part of a digital circuit, it means that input is also either 0 or 1, or we can call it a low or high. So based on that, as the AND gate having its 2 input, so the 4 possible conditions are there: 0, 0, 0, 1, 1, 0, and 1, 1. So here the 0 represents the low signal and 1 it represents that high signal. Or you can also say that 0 is nothing but that terminal is connected to ground, and the 1 it represents that terminal is connected to the positive supply. This is the difference between the 0 and 1 is there. And now the 0, 0, if you see that the first condition, A terminal is 0, B terminal is also 0. It means that both the terminals are connected to the ground. Then what is the output of? So you please try to remember that the one basic hint about that AND gate, when both the input of the AND gate, when it is 1, so this is the last condition, when both the inputs of that AND gate, when it is 1, that time only the output of the AND gate is 1. If out of these two input, if one of the input minimum एक जरी input जर 0 असेल तरी output काय असेल AND गेटचं हे 0 असणार आहे. So this is the truth table of the digital AND gate is there. And with the help of this truth table, what it indicates, आता याच्यावरून पुन्हा 4 MCQ होऊ शकतात बघा. तर if you try to remember that, you can try to remember when both the inputs of the AND gate, when they are 1, that time only the output of AND gate is a 1. For rest of the condition, that output becomes 0. And this working of the AND gate, it can be expressed in the form of equation, and that equation is called as a Boolean equation. And this Boolean equation is again the relation between that input and output in the form of equation. So what is that equation? So output Y, which is always equal to A dot B. So here in this equation, this dot sign which indicates the AND operation, or I say that AND gate is there. This is the meaning of the dot symbol in that equation, or we say that in the Boolean equation is there. Is it that clear? So please take a screenshot of it. Take it.
Yes, sir.
Now, the second basic logic gate, we call it a OR gate. Now see that OR gate, what is the function of that OR gate is there. This is the second logic gate. Now first is the symbol. Which types of symbol it is used to represent that OR gate? So this types of a symbol is used. Again, just like a AND gate, OR gate having its two input, I say that A and B, and only one output, I say that Y. Okay. Then what is the working or function of that OR gate? That can be expressed with this truth table. So as you know that there are two inputs are there. Inputs, I say that A and B, and only one output, I say that it's a Y. If two inputs are there, 4 possible conditions: 0, 0, 0, 1, 1, 0, and 1, 1. Is it right? Now listen very carefully, the function of OR gate. If one of the input of OR gate is a 1 or high, that time output is high. मग आता पहिली कंडिशन क्या? 0, 0 आहे, म्हणजे दोन्ही इनपुट 0 आहेत, म्हणजे त्यावेळेस काय राहील? आउटपुट 0 राहील. दुसरी कंडिशन क्या? 0, 1, एक इनपुट हाय आहे, that's why we say that output is 1. 1, 0, a input high आहे, that's why we say that output is 1. And the last condition, when both the आपली condition is काय? If one of the input, minimum one input must be high, that time output is high. So that this is the output of the digital OR gate is there. And now this function, it can be expressed with the help of the Boolean equation, and that equation is like that: output Y is nothing but A plus B. So this plus sign, it will not indicate that the binary addition, but actually this is the Boolean equation, and in that this plus sign indicates the OR function, or OR gate logic is there. Get it, my friend? So this is about the second logic gate. We call it OR gate. You can remember, if one of the input is 1, then definitely output is 1 is there. So please take a screenshot of it. Okay. Now The third logic gate, we call it a not a logic gate. And out of, as I say that there are total 7 logic gates are there, but out of 7 logic gate, this is the only one logic gate which has only one input and one output. This is the only one logic gate which has only one input and one output. For rest of the logic gates, the 2 input and the 1 output is there. So this is the basic difference between that not gate is there. Now see that what is the symbol for the NOT gate is there. The symbol of the NOT gate is same like a diode. But in place of bar in that symbol, one small bubble is present. And this is a 1 input. This is a 1 output. I say that input is 1. We call it A. And output is also 1. We call it a Y. Now, as only one input is there, so in the truth table, only 2 possible conditions are there. So this truth table is in between input and output. So that input is A, output is Y. So 2 possible condition, either input is 0 or input is 1. And this NOT gate will inverse the input. Means what? If the input is 0, output is 1. If the input is 1, output is 0. That's why this logic gate having another one name, we call it inverse logic gate is there. And the function of this NOT gate, it can be expressed in the form of Boolean equation, and that is nothing but output Y is equal to A bar. And to bar त्या A च्या डोक्यावरती. It means that this bar symbol, जो डोक्यावरती आहे A च्या, that will represent the NOT gate or inverse gate is there. This is the basic thing about it. मग आता तुमच्या लक्षात आलं असेल तर बुलियन इक्वेशन मध्ये टोटल 4 सिंबल यूज केले जातात. बघा कोणकोणते 4 सिंबल आहेत ते व्यवस्थित जर तुम्ही बघितलं असेल तर पहिला सिंबल आहे तो डॉट. दिस in the Boolean equation, the dot symbol indicates the AND gate. बघा याच्यावरती सुद्धा एमसीक्यू विचारले जाऊ शकतात. त्यानंतर दुसरा सिंबल जो आहे तो प्लस. The plus symbol in the Boolean equation indicates the OR gate. आणि तिसरा सिंबल आहे बार, जो डोक्यावरती A च्या काढलेला आहे. That will represent NOT gate. आणि चौथा सिंबल जो वापरलेला आहे इक्वेशन मध्ये तो आहे इक्वल टू साइन, जो LHS आणि RHS साइड साठी रिलेशन पुट अप करतो. गेट इट माय पॉइंट. सो प्लीज टेक अ स्क्रीनशॉट ऑफ इट. आणि हे जे काही बॉक्स मध्ये मी 4 पॉइंट लिहिलेले आहेत, that will be again from that 4 point the 4 MCQ it may form is there. So many MCQs it may form by using this the logic gate point is there. Please take a screenshot.
Taken, sir.
Taken, sir.
Okay. Now this is about basic logic gate. And now we will try to see that the derived logic gate is there. Give me 1 minute. बघा पहिल्यांदा आपण कंपॅरिझन करूया बेसिक लॉजिक गेटचं. आणि ती कंपॅरिझन कशी असेल बघा, की जेणेकरून त्याच्यावरती कुठला जरी एमसीक्यू विचारला तर तो आपल्याला लिहिता आला पाहिजे. द फर्स्ट वन इज AND gate. Second is OR gate. Third one is NOT gate. The symbol of that AND gate should be like this. The 2 input A, B, 1 input Y. symbol of OR gate should be like this. Again, I say that two input A, B, and output is Y. And the NOT gate, the symbol of the NOT gate should be like this. One input A and B. Is it right? If you see the truth table, then the truth table should be like this: 0 0 0 1 1 0 1 1. For OR gate, A inputs are A and B, output is 1. So 4 possible conditions. This is. And for NOT gate, only one input is there. So the only 2 possible conditions are there. Okay. So what you can remember? AND गेटचं लॉजिक कसं लक्षात ठेवणार? जर दोन्हीही इनपुट 1 असेल तरच आउटपुट 1. फक्त एकच कंडिशनला आउटपुट 1 आहे. फॉर द रेस्ट ऑफ द कंडिशन आउटपुट इज 0. OR गेटचं लॉजिक कसं लक्षात ठेवणार? एक जरी इनपुट 1 असेल तर आउटपुट 1 असेल. म्हणजे फक्त पहिल्या कंडिशनलाच आउटपुट काय येईल? 0 येईल. आणि नॉट गेटचं लॉजिक काय असेल? इनवर्स. इनपुट 0, आउटपुट 1, input 1, output 0 is there. Then this function of all these gates can be expressed with the equation. We call it a Boolean equation. So that is nothing but y is equal to a dot b, where dot is indicates the AND gate. In OR gate function, it can be expressed with a plus b, where plus sign indicates the OR gate. And NOT gate, it can be expressed by y is equal to a bar. Is it right? Okay, so this is the comparative study of these first 3 basic logic gate is there. Okay, and now let's try to derive. Let's try to see that the derived logic gates are there. Now see that what are the derived logic gate. Out of that, the first derived logic gate. Why I say that derived? Because by using the basic logic gates, these gates are derived. So I say that fourth logic gate, we call it's a NAND gate. आता हे NAND गेटचं तुम्ही फक्त टायटल जरी व्यवस्थित बघितलं तर हा NAND गेट 2 गेट पासून बनलेला आहे. 2 बेसिक लॉजिक गेट पासून बनलेला आहे.
नॉट अँड
ऍब्सोल्युटली करेक्ट. तर पहिला बेसिक लॉजिक गेट आहे तो आहे AND, आणि दिस N स्टँड्स फॉर नॉट. म्हणजे NAND गेट हा 2 बेसिक लॉजिक गेट्स पासून बनलेला आहे. तर तो आहे AND आणि नॉट. मग त्याचा सिम्बॉल काय आहे बघा. लेट्स ट्राय टू सी दॅट द सिम्बॉल. As you know that this is the derived gate which is prepared by using these 2 basic logic gates. So the symbol of the NAND gate is the same as the AND gate. बघा आहे का symbol same, but the output of AND gate, it is connected to the NOT gate so that one bubble is present in front of AND gate. Then this is the symbol of NAND gate which having it's a 2 input A and B, and this is the only one output. I say that Y. मग हाच सिम्बॉल तुम्ही कसा ड्रॉ करू शकता? जर AND गेटचं आउटपुट, this is AND gate, if it is connected to the NOT gate, then this circuit diagram, it can be acts like a NAND gate is there. So this is the A, this is the Y, B input, and this is the Y input. So here I say that input, there are 2 inputs for NAND gate and only 1 output for the NAND gate is there. So now see that what is the truth table. It means that the function of this circuit diagram. So as we know that there are 2 inputs are there. It can be denoted by A and B, and only 1 output is there, and this can be denoted by the letter Y. So when the 2 inputs are there, so definitely 4 possible conditions: 0 0 0 1 1 0 1 1. मीटिंग एंड झाली तर पुन्हा रिजॉइन करा. ठीक आहे. सो हिअर इफ यू ऑब्झर्व दॅट, आता हे लॉजिक गेट लक्षात ठेवायचं कसं, त्याची हिंट काय, तर ही हिंट आहे बघा. पहिल्यांदा हा पहिला बेसिक लॉजिक गेट आहे अँड गेट. मग अँड गेट साठी काय असतंय की जर दोन्हीही इनपुट 1 असेल तरच आउटपुट अँड गेटचं 1 आहे. फॉर द रेस्ट ऑफ द कंडिशन आउटपुट बिकम 0. आता मी याला डॉट करतो, डॉटेड बॉक्स करतो, का तर हे आपलं फायनल आउटपुट नाहीये. बरोबर आहे. मग आता प्रत्येक केसमध्ये अँड गेटचं आउटपुट कशाला कनेक्ट केलंय, नॉट गेटला. मग नॉट गेटचं फंक्शन काय, इनपुट 0 असेल तर आउटपुट 1, इनपुट 1 असेल तर आउटपुट 0. आता पहिली केस बघा. पहिल्या केसमध्ये अँड गेटचं आउटपुट 0 आहे, म्हणजे नॅन्ड गेटचं आउटपुट काय असलं पाहिजे, 1. कारण हे इनपुट हे नॉट गेटला दिलेलं आहे, म्हणून आउटपुट काय आलं, 1. पुन्हा एकदा अँड गेटचं आउटपुट 0 आहे, म्हणजे नॅन्ड गेटचं आउटपुट 1 आहे. अँड गेटचं आउटपुट 0 आहे, म्हणजे नॅन्ड गेटचं आउटपुट 1 आहे. आता लास्टच्या कंडिशनला एक्झॅक्टली रिव्हर्स. If the AND gate output is 1, so definitely NOT gate output it becomes 0. So this is the final truth table for the NAND gate is there. म्हणजे हा ट्रुथ टेबल लक्षात ठेवायची गरज नाही. लक्षात काय आहे, फक्त बेसिक लॉजिक गेट. देन यू कॅन इझिली ड्रॉ द ट्रुथ टेबल फॉर द NAND gate is there. Again, the function of this logic gate, again it can be expressed with that equation. We call it a Boolean equation, and that is nothing but y is equal to, I say that it is the combination of AND gate, and dot sign काय indicate करतो, AND gate, and on that output of this AND gate, if it is connected to the NOT gate, so that the Boolean equation for NAND gate is a dot b whole bar is the Boolean equation is that. So this bar indicates the NOT gate and the dot indicates the AND gate is there. So please take a screenshot of it.
Taken, sir.
Okay. Then after that, one more derived logic gate, we call it a NOR gate. Derived logic gate. I say that this one is a fifth one, and I say that this is nothing but NOR gate is there. आता पुन्हा एकदा याचं टायटल व्यवस्थित बघा. The NOR gate is also the combination of two basic logic gate. मग ते कोणकोणते बेसिक लॉजिक गेट आहे, एक आहे OR, and this N stands for NOT. It means that the NOR gate is the combination of basic logic gate OR plus NOT. This is the very important thing is that. Get it my point? And then see that the symbol for the NOR gate is the same like a OR gate. But as it is the combination of OR and NOT, in front of OR gate, if you just draw the bubble, then this is the symbol for the NOR gate. So it has its two inputs, A and B. Output is Y. Okay, so here I say that these are the inputs and this is the output. In simple way, if I want to explain that NOR gate, if the output of OR gate, if it is connected to the NOT gate, then this circuit diagram will act as a NOR gate. These are the two inputs A and B, and this is the output. Now see that what is the function of a NOR gate. So with the help of the truth table, we can easily remember the function of the NOR gate. That inputs, I say that A and B, and output, I say that it's a Y. So the four possible conditions, 0, 0, 0, 1, 1, 0, and 1, 1. आता याचं आउटपुट कसं बघा. आपल्याला आउटपुट लक्षात ठेवायचंय OR गेटचं. मग OR गेटसाठी फंक्शन काय, मिनिमम एक जरी इनपुट 1 असेल तर आउटपुट हे 1 असेल, म्हणजे दुसरी कंडिशनला आउटपुट 1, तिसऱ्या कंडिशनला आउटपुट 1, चौथ्या कंडिशनला आउटपुट 1, म्हणजे फक्त पहिल्या कंडिशनला आउटपुट काय येत आहे, 0 येत आहे. So this is the output of OR gate. आता हे आउटपुट कशाला कनेक्ट केलंय? नॉट गेटला. मग जर आउटपुट 1 असेल, इनपुट नॉट गेटचं 1 असेल तर आउटपुट 1 झालं. इनपुट जर 1 असेल तर आउटपुट 0 झालं. 1 असेल तर 0 झालं. 1 असेल तर 0 झालं. सो दिस इज द बेसिक ट्रूथ टेबल फॉर digital NOR gate is there. And this function, it can be expressed with the Boolean equation, and that can be nothing but y is equal to a plus b. So the plus sign indicates that OR gate, and if I take that the whole bar, it means that output of OR gate is connected to the NOT gate. Then this will act as a NOR gate is there. Is it right? So please take a screenshot of it.
Taken, sir.
Then again, now if you see that two derived logic gates we discussed till now, one is a NAND, another one is a NOR. मग हे NAND आणि NOR फक्त कोणत्याही दोन बेसिक लॉजिक गेटचं कॉम्बिनेशन्स आहेत. जसं की NAND हे AND आणि नॉट्स आहे, NOR हे OR आणि नॉट्स आहे. तसं now the third derived logic gate, which is the combination of all basic logic gates are there, and that is called as XOR, or you can write it down XOR gate like this. So this derived logic gate is the combination of AND gate, OR gate and NOT gate. म्हणजे तिन्ही बेसिक लॉजिक गेटचं कॉम्बिनेशन आहे. मग आतापर्यंत जे आपण बघितलं NAND आणि NOR, हे कोणतेही दोन बेसिक लॉजिक गेटचं कॉम्बिनेशन आहे. Then see that what is the symbol? Symbol for the XOR gate. मग याचा सिम्बॉल हा OR गेट सारखाच आहे. But at the input side, the double ring is present. And this is acts as a exclusive OR gate. Two inputs A and B, one input Y. मग आता याची बेसिक सर्किट डायग्राम जर बघितली तर ती सर्किट डायग्राम मी काय म्हणलेले, तिन्ही लॉजिक गेट्स मिळून बनलेले आहे. मग याच्यासाठी लागतात दोन नॉट गेट, दोन अँड गेट आणि एक OR गेट. लक्षात येते का? मग हे कसं बनवलं गेलंय आता मी फर्स्ट टाइम तुम्हाला थोडंसं दाखवतो, so that you will get these things. So here I say that this is the first NOT gate, this is the second NOT gate. Now input to the first NOT gate is connected together to that AND gate. This is the one AND gate, second AND gate. Now the input is going to be connected in this way. Okay, and the output of these both the NAND gate, if it is connected to the OR gate, then this circuit diagram, it can be acts like a exclusive NOR gate. आता बघा नेमकं काय झालेलं आहे. आता ही तुमची मेन सर्किट डायग्राम, ज्याला मी डॉटेड करतो, डॉटेड पोर्शन. हा डॉटेड जो पोर्शन आहे, हा डॉटेड पोर्शन, याच्या बाहेर तुम्हाला एक आउटपुट दिसेल आणि दोन इनपुट दिसेल. हा डॉटेड पोर्शन म्हणजे एक बॉक्स कन्सिडर करा, आणि तो बॉक्स म्हणजे या सिम्बॉलने डिनोट केलेला आहे. म्हणजे ऍक्च्युअली exclusive OR gate is the combination of all these three basic logic gate, where two NOT gate, two AND gate, and one OR gate it is used. And these are the two inputs. I say that A, this is the B, and this is the output line. मग आता जर तुम्ही व्यवस्थित बघितलं तर हा पहिल्या नॉट गेटला एक इनपुट आहे. बघा कोणतं इनपुट आहे? A. तर त्याचं आउटपुट काय असेल? A बार. A बार